to the problem statement. As you can see, it's quite a wall of text. I find it is summarized much better with the simple diagram. I'm sure everyone knows the formula for the area of a triangle, and can see that the intercepts are the base and height. From the equation for the tangent line, we can quickly derive an expression for the y-intercept. Remembering that we already have an equation for y, and the slope is just a derivative, we can get an equation just in terms of x, and simplify it. Remembering that y is 0 at the x-intercept by definition, we can get an equation for the x-intercept. And since we already have the y-intercept and the slope, we can get it in terms of x. Then simplify. Then we substitute in our newly found formulas to get a formula for the area in terms of x. Alternatively, since we want the area under the line, we could evaluate its integral at the x-intercept. Here's the graph of a of x. We could take the derivative by hand, but it's boring and it gets pretty complex. Instead, use a computer algebra system. I highly recommend Wolfram Alpha. Then find where the derivative is undefined by making the denominator 0. Turns out that the derivative is defined everywhere in the domain. Then find where the derivative is 0. There are 2 points in the domain, 1 and 1 over root 3. Next we evaluate the area at these points, and the endpoints. Now we need to find which of these values is minimal and which is maximal. Start by finding a common denominator and canceling it out. Then simplify, and use linearization to approximate the square root, and put the values in order.